Good day to all. I'm Dr. Reinald Pugoy, and I'm going to talk about big data applications. We're also going to discuss what data is, and actually, I'm going to show you the outline of my talk today. Specifically, we're going to define data. We're going to discuss data analytics, and of course, the applications of analytics and some summary. Let's go straight to the definition. Because in order for us to understand big data, we have to understand the actual data or the regular data. Data is a collection of facts or observations that are stored and analyzed for various purposes, such as informed decision making. And some examples of data, because we can argue that data is everywhere, like the temperature readings of the air condition recorded in a span of a particular period. Another example would be the grades of our students in a particular subject or class. Another example is you are following your favorite basketball team. So the scores of your team across different games, those also count as data. And if you are into inventory systems, that is also a notable example, and also the traffic or the number of visitors to a website per a particular day. Now, data can be classified using different categorizations. Data can be quantitative or qualitative. When we say qualitative, it pertains to words, descriptions, type of format, but qualitative, of course, it involves numbers. Data can also be structured or unstructured. When we say structured, it is organized, formatted, like what we can see in spreadsheets, tables, or databases. And it can also be unstructured, meaning that it doesn't follow a particular structure or format. Data can also be primary or secondary. This means the manner of collection of the data. When we say data is primary, then data is collected firsthand through experiments, surveys, or observations. And when we consider data to be secondary, you are simply using others' data. And before I continue, let me give you this particular trivia. Our world is generating about 2.5 quintillion bytes of data every single day. These data include texts, pictures, images, movies, music that are published or posted in different destinations or sources such as websites, online databases, government records, social media, communication, and even apps and services. And in order for us to have a good illustration of this 2.5 quintillion bytes of data, imagine a stack of standard-sized books, each containing about 500 pages. And imagine that each page holds approximately 1,000 bytes of data. Then that would mean that a single book would hold about 500,000 bytes. Therefore, to contain 2.5 quintillion bytes of data, we would require a stack of books towering to a height of roughly 500 kilometers. And that is roughly equivalent to about 1,100 Petronas towers on top of each other. Now, let's proceed to big data. Because you might be thinking we have the term data and another term for big data. It just refers to the volume of data, actually. To be more specific, big data pertains to data that is too large or complex to be analyzed using traditional data techniques. Now let us compare data and big data in terms of size. When we consider the usual data, it is typically measured in gigabytes or terabytes. As an example, 1 terabyte is equivalent to about 214 DVDs. Now, comparing to big data, it is usually measured in petabytes, zettabytes, or exabytes, such that 1 petabyte is equivalent to about 1 million standard-size DVDs. Let's proceed to velocity. The usual data is typically static, or it might be updated periodically. An example of this would be the responses that we gathered from surveys that we give to our respondents. On the other hand, big data is typically generated in real time. An example of this would be in social media. This time, let's talk about the aspect of variety. The usual data is limited to a few types, and big data can include a wide range of data types such as texts, images, and videos. Oftentimes, data is compared to crude oil. According to this particular quotation, data is just like crude. It's valuable, but if unrefined, it cannot really be used. It has to be changed into gas, plastic, chemicals, etc. to create a valuable entity that drives profitable activity. So must data be broken down, analyzed for it to have value. Then you might be thinking, what is data analytics then? Data analytics, or simply analytics, it is a process of extracting meaningful insights from data by breaking it down and analyzing it in the same way that we do with crude oil in order for us to get something more important or essential. And another quotation here, data is the new oil, is a popular quote pinpointing the increasing value of data and, to our liking, accurately characterizes data as raw material. Data are to be seen as an input or basic resource needing further processing before actually being of use. Now, I'm going to make an analogy between oil and data. Both oil and data exists abundantly. Oil can be extracted from the earth in raw form, while data is collected or amassed from diverse sources in raw format as well. Now, another aspect would be the valuable resource that both oil and data can give us. Oil, when refined, produces valuable products such as gasoline, diesel, etc. On the other hand, data, when processed and analyzed, yields meaningful insights and valuable knowledge that we can use. Another aspect would be economic impact. Both oil and data can really impact our economy. To be more specific, oil actually drives the energy, transportation, and manufacturing industries, while data obviously drives the technology, businesses, governments, and other sectors where decision-making is crucial. Now I'm going to give you a brief idea about the so-called data analytics pipeline. What is actually happening if we are doing data analytics? First phase would be data requirements specification, such that we define the needs and the scope of our data analysis project. After we make that consideration, then we proceed to data collection. We collect or gather the data from different sources. You can do this manually or even automatically. Now, after you have obtained your data, it's time to clean or prepare your data for further analysis. And that is what we call data pre-processing. It includes removing errors, duplicates, inconsistencies, and transforming the data into a format that is actually suitable for analysis. Fourth step, I'd say that this is the most important step in here: data analysis, root word analyze, analyzing the data to extract meaningful insights. And the last phase is data visualization, in which we communicate the results of our data analysis to the end users, stakeholders, so that they can make concise decisions accordingly. Now I'm going to talk briefly about the types of data analytics. we have descriptive analytics. You simply ask the question, what happened? Another type of data analytics, it's what we call predictive. You ask yourself the question, what is likely to happen? And another type is prescriptive analytics, wherein the question in here is, what should we do next? So it's based on your particular situation, which type of data analytics you're gonna use. Now, what are the advantages of using analytics in our lives? First advantage would be faster and better decision making. That we can analyze information efficiently, consequently resulting in faster decision making. Another advantage would be uncovering hidden opportunities. We know that data, again, is like oil. It holds valuable insights, and without analytics, these opportunities remain hidden, impacting strategic planning and competitiveness. The third advantage would be grounded insights. Because if we are not using data or analytics, decisions would only be based on assumptions or incomplete information, which can lead to further errors. And another advantage would be reducing bias. We can argue that data-driven insights offer a more objective view, helping us to control or mitigate bias in decision-making. Now let's proceed to some applications of big data analytics. And I'm gonna talk about some projects that my advisees have done in their MIS degree. The first one is what we call improvement of warehouse delivery performance through dashboard development. The premise here is that my student's company, Company X, do not have a real-time monitoring function for batching or making priorities of shipment orders. Therefore, delays were encountered in the pick and pack processes, causing a domino effect. That's why her main goal was to develop a warehouse dashboard for the outbound operations of Company X. These are the specific objectives. First one, reduce the late orders per day by at least 80%. And the second one is to optimize the resources and reduce the waiting time of orders per forwarder. Another example would be what we call cloud-based utility customer information system with data analytics for Barangay San Pedro Waterworks. The premise here, the problems encountered by that particular company generally involve customer service handling and financial management process. The problem, the company fails to immediately respond to a repair or emergency and timely resolve customer complaints like billing disputes. Hence, the objective is to provide data-driven decisions for efficient solutions to the problems I've just mentioned. This time, I'm gonna talk about applications of big data analytics in the government sector. Let's talk about the success story of Taiwan during the COVID-19 pandemic. As we all know, Taiwan is super close to mainland China, only about 81 miles separating them, and it was expected that Taiwan would have the second highest number of COVID-19 cases because of the distance. Now, what did Taiwan do? Taiwan actually leveraged its national health insurance database and integrated that with its immigration and customs databases to create big data for analytics. This allowed them to identify cases by generating real-time alerts during a clinical visit based on travel history and clinical symptoms. Specifically, suspected cases were quarantined at home and tracked through their mobile phone to ensure that they remained at home during that particular incubation period. And the effort of Taiwan was actually lauded all around the world. Another example would be in Estonia. Estonia actually has this so-called e-governance system. Estonia has one of the most advanced systems in the world based on data analytics. Their system, this e-governance system, allows their citizens to access a wide range of government services online, including voting, tax filing, and healthcare. They used data analytics effectively to monitor the performance of the system, optimize certain workflows, and identify areas for possible improvement. And their system is being used by the European Commission as a benchmark for digital government services. Now, you might be thinking, what are the advantages of government analytics? First, obviously, improve efficiency. Bottlenecks can be identified in workflows, therefore reducing processing times. Second, enhance decision-making capabilities that governments can identify trends, patterns, anomalies, and use this information to improve decision-making. Third, better resource allocation. By analyzing data on service demand, usage patterns, and citizen feedback, governments can optimize their resource allocation to meet the needs of their citizens. And the last one is increased transparency. Analytics can promote transparency by providing citizens with access to information about government services and operations. After I talk about the advantages, this time I'm going to talk about the challenges. First one would be data security and privacy concerns, which is prevalent in the world these days. Governments need to ensure that citizen data is protected from unauthorized access, hacking, breaches, and misuse. Second challenge would be the lack of necessary skills and infrastructure. We can argue that governments may struggle to find qualified or willing personnel and even investment in the necessary infrastructure. Third challenge would be resistance to change, wherein this may require changes to existing processes, policies, and systems. This can create resistance among stakeholders who may be hesitant to embrace new workflows or new technologies. Another one would be funding constraints. This can be costly because this would require significant investments in the digital infrastructure, personnel, and even tools. Governments may struggle to allocate sufficient funds. As a summary of my talk today, we discussed about the comparison of data and big data. We also likened data to crude oil. We also enumerated the applications of data analytics on the side of information systems and on the government. I hope that you learned from my talk today. I thank you all for listening.